to welcome Andrei Rogoff, who is an application specialist for different types of products, including AI at Nikon Europe, and with whom we have a strong collaboration because we are Nikon Center of Excellence at our facility. So he's going to talk about the AI tools that are available and what that is, basically. Andrei, please, thank you very much.
Thank you, Sylvie, for the introduction and the opportunity to speak about AI tools. I'm very passionate about them, and we have quite a few at Nikon. I'm happy to present them this morning. Because it is an educational lecture about AI, I want to start with the description and talking about AI in general. And the first question is whether it's hype or real. I think with every new year I'm talking about AI, it's more and more clear that it is real. It's not just hype. However, I will compare it to the massive transformation that we had about 100 years ago about cars. And what we learned from that transformation is that such a technology can change the world and we cannot ignore it. We absolutely need to pay attention and learn about it. However, it is not magic. For example, we had lots of hype about flying cars, but we all know they never appeared in a mass form. So clearly, even if the technology is very promising, it always has its limits, and we need to understand them. And the practical advice how we can approach this, we can understand the basics. For example, with the cars, what is gas, brake, what is gasoline, diesel, this technical terminology helps us to understand the limits of the technology and what it can actually achieve. That's why I want to talk about basic AI concepts, like fundamental concepts. There are many of them, and probably you know about most of them by this point already. However, I still want to go through them and talk about them in a very, very simple way. And the simplest way, in my opinion, how to talk about AI is to try to build one with pen and paper, literally. So I want to build a neuron model of decision making just with pen and paper. Let's say I want to have a decision making system which allows me to decide whether I want to go to cinema this evening or not. And let's say I have three criteria, free tickets, whether it's an action movie, and whether it's a 3D movie. And they're all equal in my mind right now. And let's say there is a 3D movie tonight, but I need to pay for the ticket, and it's not an action movie, it's a cartoon. So I can put a formula which I use to calculate the output based on the inputs and the current weight or importance of these inputs. And I calculate it and I get the zero, meaning no. So I do not go to the cinema. And let's say a day after, we will see what happens. Here we already we are learning a few key concepts about neural networks. What is an input layer and what is an output layer? This is very important. Input layer is what we feed in the input for our decision, and the output layer is our decision. Let's say next day we call our friends, and actually it was amazing cartoon. We really missed out. We're very unhappy. So then we can say that our input was still there. However, our output was wrong, and we need to replace it with what is called a ground truth. And here we talk about concepts like ground truth. So actually what is happening in the reality, we have labeled training data. So our description of what is the correct output is labeled training data. We should have went for this cartoon. And the full process is supervised learning because we're making decisions for the system. So we're supervising it. What we need to do after that, we need to adjust our weights. So we do a training iteration or training epoch number one. And we adjust the weights. So the new decision would be yes. So our decision should match ground truth. A next step, how to do it, we can have more inputs. And from this point of view, it's not clear what we can do, how all of these inputs are related on whether we need to take a Friday off or not. If it's not clear for us, for the AI network, it will not be clear either. What we can do, we can introduce a hidden layer with two decisions as an intermediate step. Go to cinema, we already covered, and football we can do in a similar way. And here, if we can see that we want to go to the cinema and we want to play football, we probably should take a Friday off. So like this, you can see this hidden layer of decision making helps us to manage way more inputs than initially with a simple layer. And another point is that if we just throw many situations on our decision-making system, we do not supervise it and it decides by itself what to do, then it is called unsupervised learning. Another concept that I wanted to show you is from TensorFlow background. So TensorFlow is a professional framework for developing AI applications. They have a very nice website, TensorFlow Playground, where you can play with these different situations, and you can see yourself how AI is working in training. So here we can see we have these two clouds of points and we want to distinguish between them. And we have different structure of the our network. I will go very quickly for the sake of time. Here you can see we have two inputs, vertical and horizontal lines. And in this case, we actually can do only one training iteration, and we can very easily distinguish to these clouds of dots, blue and yellow. And here you can see the training output, training loss. It's 0.02, so very low. So we very easily solve this situation. Let's go to more complex case. And let's try to solve this case with our current architecture, only two inputs with no hidden layers. Here you can see we are stuck. We plateaued our training loss at a very high value, almost 0.5. So clearly we cannot solve the situation only with this architecture. We can introduce a hidden layer with two neurons. And here you can see it's slightly better. Our training loss is 0.2, so we are improving. However, it's still not perfect. And by hovering on the neuron, you can see the actual shape which is neuron is producing. And right now, we still can follow and understand what is happening. Let's add another neuron. And now it's better. We almost solved it. So just by using these geometrical shapes, like this inclined line, horizontal line, and another inclined line, by combining them, we are better. We just change an activation function, so make it a bit more round shaped, and now this is pretty good. The main point, we still can follow what each neuron is doing yet. So here we're trying to solve another problem, and you can see that we can arrive with our current architecture with two inputs and three neurons and one hidden layer. We can add one more, and it will be even more efficient. You can see that by increasing the complexity of our architecture, we can solve more and more complex problems. However, our complexity is increasing as well. We're slowly starting to lose our understanding of how the network is actually working. And at the last example, this is very complex one. You can see we need to introduce 4 hidden layers to solve it. And a few observations here. You can see that our training is running. Our epochs will approach 1000. You can see training loss is slowly going down to 0. and we can see how the network is learning step by step. And the important point here is that now we really lost our understanding how it works exactly. We can follow neuron by neuron, but you can see it has some weird shapes. It's not clear how it is all combined in the end in order to achieve the final shape. And we approach this concept of black box. You hear that AI is a black box, and now you can understand why. Because if we want to solve complex problems, we need to increase the complexity of our neuron layers. Like here, it's 4 hidden layers. And you can see that we can investigate what each neuron is doing, but how they actually combine, this is becoming more and more complex to understand. And this is the reason why AI is referred as a black box. It's very difficult to describe exactly the logic, how it is working. So this is different from normal described programming or deterministic programming. I really recommend for you to spend some time and play with it. I think we can all learn a lot from this useful website of TensorFlow. Now, a few words about how we approach at Nikon these concepts, and we use them to solve image analysis tools. Now you know about all the main concepts of AI, and we can see how they're applied in image analysis. At Nikon, at NIS-Elements in our software, we use AI tools at all main steps of microscopy, starting with the image acquisition, image improvement, and then extracting the data. So if we start with image acquisition, we use autofocus, then we use the noise clarify and restore to improve the image and extract data with many functions. You can see there are two different types, whether it is Nikon pre-trained, so it means you can just use it directly, or in green are labeled where user training is required. This is this supervised learning that I was mentioning before. You need to label your data in order to train your network, and then you can use it afterwards. Acquisition with AI. We have our automated microscope, GI, which is a flagship in this respect, which uses inference in order to predict the correct focal position. So we can acquire only a few planes, like 2, 3, 4 planes, and then we can predict the correct focal position of your sample, of your cells. It means that autofocusing is way faster in this respect. So then you can autofocus on cells in bright field, which is very difficult task, as you know, and then you can run cells localization AI, which can label your cells in bright field, so you can use them for localization of the cells or a simple cell count. All in bright field, unlabeled sample, and very quick. We also have a button for auto signal. This function allows you to very quickly and in an automatic way define your excitation parameters and your camera parameters for detection. So your signal has correct dynamic range, and all parameters are set up for you in one click of a button. Then an example how we can use how we can use AI, how we can train it. So here I'm showing you a workflow how to use enhanced AI. And what does it do? So here we have a high quality signal and low quality signal. This is our training data set. This was a convaria sample acquired on confocal. So we just go to NIS AI, train, very easy drag and drop menu. where you can just drop what is source AI channel and ground truth. So we want to go from low signal to noise to high signal to noise, 1000 iterations, and put the name of our result. And then you press train. You will see this progress of epochs or iterations and the training loss, very similar to what we have seen in Tensor Playground. And the training is done locally on your GPU. And you can see the training loss going down. And then it takes a few hours, depending on your training data set and what you want to achieve. Here you will see the graph of training loss and how slowly it will go down to zero. So here you can see this full training will take about 3 hours, but yeah, here we will just press finish in a bit, and we can just show how to use this network when it is ready. So once your training is done, here we opened another file with low and high signal to noise channels, and we can use low signal to noise channel in order to predict or generate high signal to noise channel. So we can just go to NIS-AI, Enhance AI. We connect our input channel to low, and we use our training dataset. We use the network that we just trained. And here, as you can see, it works very fast. It takes maybe about a second to load to the memory, and the progress is very quick. So this is high signal to noise channel, which was generated by AI, and we can compare it to real world high signal to noise channel. And as you can see, they're very similar. So we go in from here, from this very noisy input to this high signal to noise channel. And this was trained on our own data. As you have seen, the main workflow is very easy. It's a few clicks, drag and drop, and you have your AI network trained for your usage. What other tools we can use? So we have the Noise AI. This is pre-trained. You don't need to train it yourself, and you can start using it directly. Clarify AI removes autofocus blur. It is also pre-trained. You can start using it directly. Cell localization, as I mentioned, helps you to localize and count your cells in bright field. No labeling is needed. Enhance AI, I just showed you how to train it, and this what the usage would be. You can go from low signal to noise to high signal to noise. The possible application here is, for example, a spinning disk. If you want to be gentle on your sample, you trained once how to go from low signal to noise to high signal to noise, and then during your day-to-day, you just acquire your gentle images of your sample, and then you enhance the signal with Enhance AI. The network that you need to train and it gives you the best results on your training dataset is Convert AI. It can predict another channel. So we gone from one channel image to two channel image. Here we do predict nuclei in DAPI from just Vici cytoplasm channel, meaning that we don't need to put to expose our sample to UV, and we don't need to label in DAPI our sample. And Segment AI, it's another network that you can train on your own data to get the best results. Here we can see segmentation and detection of cells in bright field, which is again a very difficult task to do. And we have a particular module for segment objects AI, very similar to segment AI. It just taken into account that touching objects should be separated. We also support partial segmentation. So here you can see a cancerous tissue where you can just segment only parts of the tissue, what is positive control, what is positive, what is negative, and then you can run on the full tissue and get your segmentation in color in three channels, red, green, and blue on your full tissue. Also, you can segment in 2D your images and then train them for segment AI and then reconstruct in 3D and have, for example, 3D detection of neurons in this way. And in the last few versions, we added Python support. So here, this is an example how to use scikit-learn module from Python for unsupervised learning. That's what I mentioned at the beginning of my presentation. Here we have pollen, different pollen types, and we can detect them with segment objects AI of NIS-Elements, measure their features like color, shape, size, circularity, and so on, and then run unsupervised learning on the table of the features and automatically classify them in 4 different classes. And as you can see, it is fully integrated in our general analysis 3 image analysis pipeline. So you can do your segmentation and image cleanup with visual programming tools. And when you need to add your Python code, you can just add it as one task. So we have seen the main fundamental AI concepts because I think it's very important to understand them before using the AI tools so we know what it can achieve and what are the limitations. And we have seen how in these elements we use this AI approach for image acquisition, image improvement, and image analysis to extract the data. We have some pre-trained models by Nikon that training is already done and you can use them directly, or some modules you can and should train on your own data to get the best results. And a small remark that in the last few previous NIS-Elements versions, we added Python support. So if you feel that you want to use something very particular, which is covered by Python open source libraries, you can do this as well nowadays. Thank you for your attention, and this is all from my part.
Thank you very much, Andrei. So I would like if anyone has used AI so far to analyze their data or even, I guess, to focus or do any such things. Yeah, Robin?
I just
You have?
yeah, I thought I was gonna raise the hand for.
Yeah, yes, yes. Okay, good. Look, great. Great. And what is your experience? Did things work? Was it helpful?
I mean, I haven't used the Nikon, of course, and I've used AI primarily for segmentation. But I think for things that are quite common, so there's let's say, a backbone of training already done for like nuclear segmentation and things like this. It's super robust and a lot more efficient compared to like classical image analysis where you have to set thresholds and everything.
What type of AI have you used?
So, I mean, I've worked with different architecture that we have trained ourselves, and also with, for example, meta segment anything model. Yeah.
Great. Yeah. Excellent. Manjay, what did you use?
I used cell pulse for segmentation the cells, and after training, it works better than ImageJ, I would say,
Yeah.
because it didn't stain the nucleus. So I only segment with the cytoplasma. But for me, I don't know how to implement the cell pulse to my workflow now, so I'm still figuring out.
Oh, I see. Okay. That's interesting. Yeah, so you have basically you are training the software to recognize the nucleus because it's black. It's a black hole in the cytoplasm. Is that it?
Because I have a basic expression in the cytoplasma, so I only segment the cytoplasma for the reference of segmentation.
Ah, okay, but and then you can find the nucleus from there.
I just want to segment the single cells,
Oh,
so I
you want to segment the whole cell. Yeah, yeah,
yes,
yeah, yeah.
so I
Very
can
good.
count the dots
Yeah,
per cell.
yeah. And I guess there are some people maybe who have, some of you are using an autofocus. I think there are a few who have been using a slide scanner. Maybe that might be also somehow driven by AI.
I was using the autofocus on the spinning disk. Maybe I didn't do it correctly. I just put my sample there and then I click autofocus, but
And did
the
it work?
effect was not very good.
Okay, okay. But that was an autofocus. Which spinning disk are you using?
Nikon spinning disk V3.
Right. So this is not based on AI. This is a hardware autofocus, I think. And so
Yeah.
it's not based on AI. It's so and again it depends on you must have a refractive index interface. So if you have a perfect sample and you have matched the objective to then it's much harder for it to be reliable. But if you have a refractive index interface, it's actually quite reliable. And also it relies on your sample being on the cover slip, right?
Yeah,
So
yeah, it's on
it,
the cover slip and I have that RI interface, but when I
okay.
clicked this button, I think there was no change.
Okay, okay.
Yeah,
So maybe we can have a look because we use it all the time.
yeah.
Uh, and yeah, it relies on some things like, for example, your cover slip being clean and this type of things. And if the cover slip has some mounting medium on it, then yeah. So all these sort of things have to be just good, but it's very robust, really. But Andrew, sorry, thank you very much. Robin, you had the question.
Yes, I just had a question for Andy. I don't know if I missed, but do you have some kind of either that you have to train yourself or pre-trained for identifying regions of interest to image? So, for example, you do a wide field image, and then um, you have, let's say, a couple of areas that you want to image, and then you can use the AI software, either if you pre-train it to go to these areas and then do the high magnification imaging, for example.
Yes. So Segment AI is where you can train your own network on your own data to have segmentation and detection. And then AI tools are fully integrated in General Analysis 3 that I was showing, and also in Jobs as well. So Jobs is our acquisition module. General Analysis 3 is our image analysis module. AI tools are fully integrated there. So you can combine everything and you can have what is called smart microscopy. I think you've heard about this concept before, where you can use AI to detect, for example, this type of objects, cells in bright field in this situation, and then you can pass this binary mask to jobs for image acquisition. You can revisit these coordinates on the stage, switch objective, do autofocus, and continue acquisition from there.
Very cool. Thank you.
Yeah, so that is a very nice feature with this smart microscopy and Jobs. Very good. You can input AI as well in it, so Jobs is brilliant.